In the last two lessons, we have talked about what to do when solving a quadratic by factoring. And step one is to make sure that your right side is 0. So if it's not 0, you need to move that over. So this is going to leave me with k squared plus 8k plus 12 equals 0. Then if I have a GCF, that's step 2, I'm going to factor that out. But in example 1, I do not have a GCF. And in example 1, a is 1, so I can jump right in to factoring. I know that k times k is k squared. And then I need factors of 12 that add to 8. I'm thinking that is a positive 6 and a positive 2. Since 6 times 2 is 12, 6 plus 2 is 8. Now from here, I'm going to take each term set them equal to 0. Then to get k by itself, 6, to get k equals negative 6. And k equals negative 2. In example 2, again, my first step is to subtract this 8. So I need that right side to be 0. So say 12, a squared, remember this is a 2, this is an a, this is a 2, plus 16a minus 50, minus 60, since negative 52 minus 8 is negative 60, equals 0. From here, if I can factor out a GCF, I'm going to factor out a GCF. I'm actually going to erase example 1 so that I get a little bit more space. I think I can factor out a 4. So if I factor out a 4, I mean, remember when you factor out a GCF, it means you're going to divide. So it's going to be 3a squared plus 4a minus 15 equals 0. And then at this point, I don't have a GCF anymore. I pulled that out. So I can just divide by 4 to get rid of it, so I don't have to worry about it anymore. Because then this will be 3a squared plus 4a minus 15, still equal to 0. Then I need to solve using AC split. Since a is greater than 1, that's the key indicator there. If a is greater than 1, you have to use AC split. So I'm going to multiply a times c. It's going to give me a negative 45 and a 4a here. So multiplies to negative 45, adds to 4, that's going to be a positive 9 and a negative 5. So from this point, I'm going to rewrite this part, except where I'm not going to include the linear term. Instead, I'm going to use these. I'm going to have 3a squared plus 9a minus 5a minus 15 is equal to 0. Then I'm going to factor by grouping. So we're going to pull out 3a. It's going to leave me with a plus 3. I'm going to pull out a negative 5 since I want my signs to be the same. I'll leave me with an a plus 3. So that means I'm going to have a plus 3 times 3a minus 5 equal to 0. And then just like before, I'm going to set each part equal to 0 and solve for a. A plus 3 equals 0. 3a minus 5 equals 0. So I'm going to get a equals negative 3. I get 3a equals 5. That means that a equals 5 over 3. This is the last two lessons that we talked about this. Today we are going to talk about solving by taking the square root. So, back when we did that exponent unit, we talked about something like 3 squared. We know that 3 squared is the same thing as 3 times 3. And that is equal to 9. But what's interesting is that negative 3 is a quantity squared. That is negative 3 times negative 3. We know that 2 negatives multiplied together equals positive. So this is also positive 9. So a square root is the inverse operation of a squared. Just like subtraction is the inverse operation of addition, they reverse each other. This is the exact same thing. A square root is the inverse operation of a square. And there's something important about taking the square root because both 3 and negative 3 squared equal positive 9. When you take the square root of 9, you're going to put this symbol. This is a plus sign and a minus sign. That means your answer is a positive 3 and a negative 3. There are actually 2 solutions. Where you're writing this, put a big star around that. This is what gets people a lot. Go ahead and hit pause, write down these steps. We're going to get the grouping that has the squared by itself. You're going to take the square root and include that plus or minus sign so you know there are 2 solutions. Then you are going to make sure the variable is by itself. So here's how this works. If I have the square root, a squared equals 54, I need to get a by itself. So the inverse operation of this squared, that I need to get rid of, is a square root. And so these are going to cancel each other out. So that's going to leave me with a equals square root of 54. Now, if you plug them into a calculator, you'll notice that that is not a nice number. It's a decimal. And that's okay. We're going to write that. We're going to round to the nearest thousands, nearest 3 decimals. Now, when you do this, you cannot forget that there are 2 answers. Positive 7.348 and a negative 7.348. You could write it like this if you wanted, or if you don't really like that symbol, you could write it as this. These are the same thing. This one is just written out a little bit more. They're the same thing. Now, example B, we have a squared equals negative 9, and we know that the inverse operation of squared is square root. So these are going to cancel. I'm left with a equals plus or minus square root of negative 9. Now, if you plug this in your calculator, you're going to probably get an error message. It should say like non-real answer or negative square root or something. We do not have the methods to solve for a negative square root in Algebra 1. So if you have a negative square root, we cannot continue the problem. So our answer here, we talked about this a little bit in 9.1, is no real solution. A negative square root produces an imaginary solution, which we will not talk about until Algebra 2. Now, in example 2, my variable is not by itself. So before I can square root, I have to get the variable by itself. So a 9n squared equals 36. I need to get rid of this 9. Since it's being multiplied, the inverse operation of multiplication is division. So I'm going to be left with n squared equals 4. And then to get rid of that squared, I'm going to square root both sides since those are inverse operations. These are going to cancel. It's going to leave me with n equals plus or minus square root of 4. And the square root of 4, that's a perfect square. So that's going to be left with 2. Square root of 4 is 2. So my answer is plus or minus 2, which is the same thing as positive 2 and negative 2. But you got to have both answers. This is crucial, or the written out positive and negative 2. In example B, to get r squared by itself, I've got to get rid of that 6. To get rid of it, I'm going to subtract 6 from both sides. It's going to leave me with r squared equals 10. Now once I have that, get that r by itself. I'm going to square root and get r equals plus or minus square root of 10. And if you plug that into your calculator, you should get 3.162. Plus or minus, of course, positive 3.162, negative 3.162. Now, I'm going to put the answers up for this, and I want you to do the work yourself. If you are not getting an answer, raise your hand so that I can help you. Should be getting these answers. If you're not getting that, raise your hand so that we can figure out what's going on. Now, example 3 is slightly more extensive. There's a couple of things we can do before we can apply that square root. We first have to get rid of this negative 8 or this positive 8 because we're doing the reverse of PEMDAS right now. So we're going to get rid of addition and subtraction first. This is going to give me 2n squared equals 40. And I'm still not ready to square root because I have this 2 here. So to get rid of that 2 that's being multiplied, we use the inverse operation of division. So we give me n squared equals 20. Since it's just the n and the squared, I can apply that inverse operation. Those will cancel. Plus or minus root 20. That is going to give us plus or minus 4.472. In 3b, to start getting this b by itself, I need to first subtract 3. We have 16 b squared equals 4. This is 6. Then to get b squared by itself, I'm going to divide by 16. So I've got b squared equals 4 over 16. Now you could simplify later. We could see now that they're simplifying. These have a common factor, so I can simplify this. If I divide both of these by the common factor of 4, it means b squared is going to be equal to 1/4. Now, when I square root this is interesting. With square root fractions, you are allowed to take each square root separately. So I can rewrite this as square root of 1, plus or minus square root of 1 over square root of 4. So I know that the square root of 1 is 1, square root of 4 is 2. So that means b equals plus or minus 1/2. Now, these are interesting because the 2 in example 4a is inside the parentheses, the square root of that. That means this whole part is being squared. So I'm actually going to start by getting rid of that square. Since this whole chunk is being squared, I'm going to square root the whole thing. So that's going to give me, these are going to cancel. I'm going to have n minus 2 plus or minus square root of 16, which we know square root of 16 is 4. Now, this is where it gets a little interesting. To get n by itself, I now have to add 2 to both sides. So I'm going to have n equals plus or minus 4 plus 2. Now, we can simplify this a little bit. If I were to have rewritten this 4 as plus 4 plus 2 and minus 4 plus 2, then I can get an exact number. This is going to give me 6 and negative 2. So my answers, my solutions to this quadratic are 6 and negative 2. Let's do the same thing with example B. Since this whole term is being squared, I'm going to square root both parts. So we're going to have b plus 3 equals plus or minus square root of 7. And square root of 7 is 2.646. And to get b by itself, I'm going to subtract this 3. So I'm going to have b equals plus or minus 2.646 minus 3. And if I write that out, b is equal to positive 2.646 minus 3, and b is equal to negative 2.646 minus 3. So positive 2.646 minus 3. This is equal to negative 0.354, and negative 2.646 minus 3 is equal to negative 5.646. Now, I want you to try these yourself. I will put the answers up. If you're not getting these answers, grab these that I can help you. Make a note about example D, since we didn't talk about something specifically like this. So I have to get this squared part isolated. So before I can do the square root, I have to subtract 4. Then I can apply my square root. Go ahead and grab the homework. Get started.